Hey guys, so the next problem that we're going to talk about is lost stone weight. You are given an array of integer stones, where stones of I is the weight of the ith stone. We're playing a game with the stones. On each turn, we choose the heaviest two stones and smash them together. Suppose the heaviest two stones have weight x and y, with x less than or equal to y. The result of the smash is, if x is equal to y, both stones are destroyed. And if x is not equal to y, the stone of weight x is destroyed. And the stone of weight y has a new weight, which is y minus x. Now at the end of the game, there is at most one stone left. Return the weight of the last remaining stone. If there are no stones left, you're going to return 0. So what you're given, you are given an array of stones, and where stones of I is the weight of the ith stone. So this is the weight of your 0th stone, the weight of your first stone, second stone, third stone, first stone, and fifth stone. We are playing a game with a stone. Okay, we're going to be playing a game. What is the game? On each turn, we choose the heaviest two stones and smash them together. Suppose the heaviest two stones have x and y, with x less than or equal to y. So what is going to be the smash look like? So first, let's combine 7 and 8 because that is the two largest weight of the stones to get 1, because both are different. You see, if x is not equal to y, let's have x as 7 and y as 8. Now when both of them are not equal, a stone of the weight x is destroyed. That means 7 is destroyed, and the stone of the y will have a new weight now, which is 1. You can see here that you eventually got your array lesser because 2, 7, 4, 1, 8, 1, there was 6 elements at first, now you got this. So basically you just replace 2, 4, 1, and the y value is the one that is replaced. So you can see 8 is now replaced to be 1. Now let's have another example. We combine 2 and 4 now. We're now using the new stone weights. Now we got a new stone weight. We got 2 and 4 to be the largest. Now they're not the same, so what you should do? Yes, destroy the x, take the y, 4 minus 2 is 2. Then we're going to combine 2 and 1, which is this one because they are the largest. And 2 and 1 destroy the smallest, which is 1. 2 minus 1, so we're going to have this replaced with 1. Now we're going to have only 1, 1, 1. We combine 1 and 1 because they are the two largest stones that we have here. When you have equal, x is equal to y, both the stones are going to be destroyed. So we're going to destroy both of them. That means nothing is going to be included in the stone's weight. So we're going to have only one stone left with a weight of 1. So that's the last standing stone over there. And when you have just one stone, just return it as is. Alright? If you have a look at the problem, and the problem says that the end of the game there is at most one stone left. When I say at most, you could just return at most one stone's weight. Okay, that should be one stone. Or if there are no stones, you could just return 0. So what is the most important red that you need to look onto this? The highlighted one, which is the heaviest two stones. The heaviest among the arrays that you have. So how can we potentially solve this problem? Before we jump onto the code, I would like to simulate this game again. So let's play this another time. So over here we have the stones. The stone weight 0, 1, 2, and 3. Now what happens over here is we take the two largest stones. So what are the two largest stone weights? We got 10 and we got 6. Now what is the value of x and y? The x is going to be the smallest and the y is going to be the largest. So the 6 is the x value and 10 is the y value. Now what happens here? We need to destroy the x value. So we should no longer take the x value. So we destroy it. And then we take for the y value, we're going to take y minus x, which is 10 minus 6, and that's going to be 4. And we need to replace it exactly where the array was. So here you can see at the 0th index, we know 10 was there. So right now, our new stone weight is 4, and we have destroyed this stone. Basically, we just smashed both of them together. Next off, we have the remaining 4 and 4. Well, let's go ahead and pick up the two largest stones, which is both of them. And right now, what we're doing, we are destroying one of the stone, we're smashing both together. So of course 4 minus 4 is 0, and we never include 0 in our stones. So basically both are actually destroyed. So according to the question, this is the reason both are destroyed. And we have only one stone left, which we could return as the last stone value, which is 4. So what do you think we're going to use here? When I say that we need to have the heaviest two stones, we need to store the maximum value at the top of your data structure that you're planning to use. So if you have seen my last video that I've used min heap, this is the same concept. We're going to be using max heap in this concept. Why do we choose to have the max heap? And one thing that we're not going to do in this is we aren't going to replace the new values onto our array. Okay, so it's just a, there's, so that one we aren't going to do. And another thing that aren't going to do on our code that we just simulated here is this one. We aren't going to replace the new values onto our array, and we are only going to use our heap data structure throughout this video. We aren't going to use anything else. So what are the steps we're going to do exactly? We are going to create a max heap. So once you have a max heap, we're going to put all the elements. We're going to put all the elements inside our max heap. So what this max heap is going to hold on to is the two largest elements at their top. So eventually you will get two large elements. So we're going to pull them out. So we're going to pull them out and we'll store in two variables. So we're going to have two variables. Let's have x and y, and we're going to do pull, okay, for this one and this one. Since it has the largest value, we need y to hold the largest value. We're going to do the first polling for y, since it's going to hold the largest first value and largest second value. Okay, so min heap holds that, and max heap is going to hold this. And if my heap is empty, I can return 0. Else, I'll just return heap.peak. And what do you think all these must run on? Like how much times these things must run on? So two elements are going to be at their top. We're going to have two variables, and we're going to pull 2 times. Now, you might be asking me a question. Like in my last video, I have mentioned that it doesn't actually store the order that we want. It doesn't store, it stores the largest element at the top. So whatever element is going to be at the first is going to be the largest, and the other elements are going to be in different order. It doesn't matter. Like for example, let's have 8 to be the largest element. Let's imagine. So in our data structure, in our max heap data structure, we're going to have 8 at first. But later on, we're going to have smaller numbers, like 5, like 4, and you might see 2 coming after 3. So this is also something that you could notice. It isn't going to be on the same order as we looked for. It might be in a different order, or it might be even in a sorted order. But the thing is, you have the top, you're going to have the largest element. So when you pull it out of it, it's going to again rearrange these elements. So we're going to have the largest element at the top. So we're going to have 5, 4, 3, and 2. So the next time we're going to pull out another number, it's going to always ensure that we can get the largest number. So don't think we're like pulling it 2 times, and no, it's always going to maintain the largest number at the top. So you're always going to get the largest number from your array. So you got your 2 largest element, and then let's say 5 and 8, and you smashed it. Yes, you smashed it. So you smash it, and then again you put it down there. So how do you do that? How do you do that logic? So once you pull out y and x, which is your 2 largest element, first we're going to check if y is not equal to x. Okay? And when y is not equal to x, that means when both of these values are not equal, we need to again put inside, we're going to offer, but what we're going to do is y minus x. We're going to smash them together and then put that in, put the value in, right? That is the rules that we looked at. Now another rule that we're going to ignore that we did on our thing is we aren't going to replace the new values onto our array. That means we aren't going to touch our array in this case, but we are also not going to insert when they're equal. So we aren't even going to write any condition. So we're not going to insert or do any kind of operation when they're equal. So when they're equal, it's just going to ignore and isn't going to do anything. So let's code out whatever we wrote there. So let's go and create a max heap over here. Priority queue, integer, pq equal to new priority queue. And once we're done, we're going to add all the turns inside of the priority queue so that we actually know what are the 2 largest elements. So we're gonna have like stones. So we're gonna add all the stone weight onto pq.offer. We're gonna add all the stone. And what did I tell you? Yes. So we're gonna continue this until our pq.size is actually less than or equal to 1. So it's going to be like 0 or 1. Until then, we'll continue doing it. We'll have int y, which is going to be the largest. We're going to have pq.poll, and int x, we're going to have pq.poll. And once we have both of these, we're going to check if they're both different. When they're both different, we're going to offer y minus x, and then we aren't going to do anything when they're the same. And if pq.size is ever going to be 1, we don't want this to go beyond that, so it's going to return the pq.poll, or else we can just return 0 if it isn't happening, and make sure we add it and keep on repeating the process until we do so. So the most important thing that you do is alright, so yes, so integer, we've given integer. I'm so sorry about this one. We're gonna run that. I'm so sorry about the while one, the while loop, and also we need to do collections dot reverse order because I already mentioned that it is gonna have a min heap, so we don't want that. Reverse order. Now what it does is it just reverses whatever the min heap does. So you get a min heap and it just reverses it, so you get a max heap. Okay, so when it starts, it just reverses that and you get a max heap. Okay, let's run the code. Run the code. Okay, so the output is 0, but the expected is 1. Okay, so we did return pq.poll like if our pq size is actually equal to 1. Okay, so what we're gonna do is we're gonna return. Oh, I'm so sorry. Like, I'm so sorry. I just did a poll over there. Okay, I don't know what I'm doing. But I just did a poll, but it should be doing a peak. Oh gosh, what is wrong there? There's a wrong answer. Again. Okay, okay, so what is happening is the pq.size is greater than 1, okay? Let us try this now. Let's try this. Oh my god, why am I doing this? I don't know. Okay. Yeah, so we're gonna put an equal to there, and then let's try it. Because it didn't stop at 1, like, okay. Okay, the poll value is actually null. Because, you see, when you have only one value in your while loop, when you have only one value, when you have only, like, let's say 1 comma, like, let's say it's just 5. So when you have only one value, and when you do a poll over here, it's null. Because when you do a poll, you remove the 5, so y value is actually 5, but you don't have any values to poll here. So when you do that, it comes out to be null. So let's stop before we even reach the size of 1. And yeah, like, let me just check it at the initial itself. So when I say pq.size, size is like equal to 1. Sorry, equal to 1. I'm just gonna return pq.peak. Okay, I'm not gonna allow it further to go inside of that. So I'm just gonna remove it right over here. I'm not gonna allow it to pull. Let's see. Oh shoot, man. Oh my god. Okay, I guess I'm making things worse, guys. Like, see, the expected is actually 1, but I'm like, it's exceeding the while loop. It's completely exceeding the while loop. Let me just put that on the out. PQ dot peak. Okay, if there is anything there, like PQ dot size is equal to 1. If it is 1, you pick it, otherwise you just return 0. And let's check out how this goes. Let's see how it goes. Oh, come on, buddy. Yay, it worked.